Hello friends, today we are going to see the concept of ladder operator. So first you know that ladder and CD. So step by step either we are going to in upward direction or in downward direction. Okay, and it acts as the operator, means when we are rising by step, so that is the ladder operator in upward direction, and when we are lowering down by step with h cross, then it is a lowering operator in and therefore this is the ladder operator. Last we have seen already. So this commutation relation between Lx Ly is equal to IH cross Lz, Ly Lz is equal to IH cross Lx, and Lz Lx is equal to IH cross Ly. And this minus sign because of the reverse direction, rotationally reverse direction. So these are the commutation relation between this Lx, Ly and Lz. Okay, so these components of angular momentum. Now we have to define this ladder operator as L plus is equal to this Lx plus ILy, and L minus is defined as Lx minus ILy. Okay, and therefore we have to see what is the commutation relation between Lz L plus and Lz N minus and L plus L minus. So there are three exercises. One is Lz L plus, the commutation relation between these. Second is Lz L minus, and third one is L plus L minus. So this commutation relation gives how that angular momentum operator Lz operates on raising and lowering operators, or as a ladder operator. Okay, and therefore first we see this is Lz L plus, and therefore this Lz L plus is equal to Lz, and L plus is nothing but L plus is Lx plus I Ly. Lx plus I Ly is equal to, so this can be written as this Lz Lx plus Lz ILy, is equal to this Lz Lx plus I into bracket Lz Ly. Okay, and from the commutation relation between Lz Lx, so see this Lz Lx is equal to IH cross Ly. So this commutation relation is nothing but IH cross Ly. Okay, and we have to see this Lz Ly is a minus IH cross, and this is the minus IH cross Lx, minus IH cross. Put these values here, and is equal to, so this IH cross Ly plus I into bracket minus IH cross Lx. Okay, now this minus multiplying inside I square is equal to minus 1, and this minus 1 cancel, and it becomes IH cross Ly plus H cross Lx, is equal to, we wrote this, so this H cross Lx plus IH cross Ly. Okay, now this H cross you take the common outside, and it becomes this H cross into bracket Lx plus ILy, Lx plus I. And what is this Lx plus ILy? So this Lx plus Ly is nothing but the L plus, okay, is equal to this H cross L plus. H cross L plus means this Lz operates on L plus, then we get the H cross L plus. So with the eigenvalue, this can be written as, this can be saying as let this Lz Lx L plus operates on any state sign, is equal to H cross L plus sign. H cross L plus sign means this shows that the state of the system is increases by the H cross. So this H cross is the eigenvalue in one step. So increase by the H cross. Second operator increase by H cross. So this is the L plus and a ladder operator. Means when this Lz operates on L plus, the system is increasing by the eigenvalue H plus. Okay. Similarly, like that, this Lz operates on L minus. Lz operates on L minus. Let's see what happens. So commutation relation between the Lz L minus is equal to so this Lz and L minus is what? L minus is Lx minus I Ly. Lx minus I Ly is equal to, so this is the relation between this Lz Lx and this can written as the plus this Lz I Ly minus Ly. Okay, and this can be saying that you take this minus I outside and this becomes minus I and this Lz. Okay, is equal to this Lz Lx minus I Lz Ly, and we know that this Lz Lx is equal to I H cross Ly is equal to I H cross Ly, and this Lz Ly is minus I. So this minus I H cross Lx, minus I H cross Lx, and therefore this can be written as I H cross Ly, minus of I into bracket minus I H cross Lx, minus I H cross Lx. So this multiplying inside I square 1 minus will gone is equal to I H cross Ly minus H cross Lx. H cross Lx, we get it, and this you take the H cross common here, and therefore it becomes Lx minus Ly. Lx minus Ly. And what is this Lx minus Ly? See, Lx minus Ly is L minus, and therefore it is equal to L minus, and therefore when this relation Lz L minus is equal to H cross L plus. The same thing when this Lz operates on this L minus lowering operator, then you get the system by in lower direction by the amount by the eigenvalue minus H cross, means one step back. So when this H plus is there, the system will raising in by the one step, that is the H plus, and when this L minus is there, so that is the system is lowering by the one step, that is the H minus H. Okay, so this minus H, and like this is the ladder operator. See that this a third relation, this L plus L minus is equal to this L plus is nothing but the Lx plus Ly, and L minus is equal to Lx minus Ly, and therefore this L plus L minus is equal to the commutation relation is between Lx plus ILY and LX minus ILY. So by the commutation algebraic rules, so this is the LX minus LX minus ILY, then ILY LX and minus I square LY. So this LX is 0, LY is equal to 0. What remains is the middle two is minus LX and LX we know that is the IH cross LZ, and LZ we know that is the minus LX is equal to minus LZ. When we reverse the direction, it becomes minus H cross LZ, and therefore one is the plus sign, another is minus will get cancelled, and this H cross LZ plus H cross LZ is equal to 2H cross LZ. Okay, so this is the commutation relation between ladder operator plus and minus, L plus L minus is equal to 2H cross LZ. Raising and lowering of angular momentum operator. So this diagram shows one step by lowering and one step by raising. Hello friends, today we are going to see raising and lowering angular momentum operator. As we know that this L plus and L minus we have defined in last part. Now let the system, the state, mth state of the system is represented by SIM, a wave function SIM, and when the LZ, angular momentum operator LZ, acts on SIM, it gives this MH cross SIM, MH cross SIM, and therefore this MH cross is eigenvalue. When this LZ operates on a SIM of a state, psi state, is equal to MH cross SIM, where the SIM is an eigenfunction and MH cross is eigenvalue of LZ operator. Okay, and therefore now we have to see this L plus is defined as L plus is equal to LX plus RLY, and L minus is defined as LX minus ILY. So this is the L plus and L minus, so raising and lowering operator. Now we have to see what happens when this LZ operates on this L plus. So that is, we say that the LZ operates on L plus SIM. Then what will happen? Therefore, this L plus is nothing but is equal to this L plus ILY SIM, and LZ is operates on that. LZ operates on this state SIM of raising operator. Now we have to see the final result what will come. Okay, so multiplied inside is equal to this LZ LX plus ILZ LY is SIM. Okay, now we are going to see what is this value of the LZ LX and LZ LY, and we know that this LZ LX minus LX LZ is equal to IH cross LX, and this means this is the LY. Okay, so that we have already known this relation, and this LZ LY minus LY LZ is equal to minus IH cross LX. This minus because of the reverse direction. Okay. Now from this equation find out this LZ LX and therefore transfer here. So this LZ LX is equal to I H cross Ly plus LX LZ and this LZ Ly is equal to minus IH cross LX plus Ly LZ. So these are the put this value of the LZ LX and LZ Ly in above equation we have is equal to so this LZ LX is nothing but IH cross Ly plus LX LZ plus I into bracket that is minus I H cross LX plus Ly LZ plus Ly LZ and total is a psi is equal to so this we write this LX LZ plus IH cross Ly okay, plus I Ly LZ and multiplied inside that is becomes L square. Okay, that L square I square is equal to minus 1, this minus plus, so this is the H cross LX. Okay, bracket completed psi m. Now we are writing this this term and this term common and this will correlate and therefore this will write as the LX LZ plus I Ly LZ plus the remaining things. So that is the H cross LX plus IH cross Ly is psi m. Okay. Now here from this you take the common LZ and from this we take the H cross. Okay. So this then treatment is equal to so this LX plus ILY LZ plus here you take the common H cross. Okay, and therefore this H cross into bracket LX plus ILY. This psi m operates on both. Now you operate from this inside multiplied inside and it becomes that is the LX plus ILY LZ psi m plus H cross into bracket LX plus ILY is psi m. Okay, but we know that when this LZ operates on psi, we get the MH psi m, and therefore this LZ operates on psi m is nothing but MH cross psi m. Okay, and therefore so this is nothing but the MH cross psi m, and we can write as this LX plus ILY MH cross psi m plus H cross into bracket LX plus ILY is psi m. Okay, now see what happens here. This LX plus ILY is take the common and this can be written as is equal to LX plus ILY common remains is MH cross psi and H cross psi. H cross psi will take the common here and therefore this becomes into bracket MH cross plus H cross is psi m. Okay, now so this is the constant, we take the scalar multiplier, so this is the mh cross plus h cross Lx plus Ily is psi m. LH is cross I psi m. So let us see, when this Lz operates on psi m, we get mh cross psi m. But this Lz operates on L plus. When this Lz angular momentum operator operates on the L plus, we get mh plus h, means the eigenvalue is increased by the h cross. Okay, and therefore this is called a raising operator of angular momentum. Similarly, we can prove that when this Lz operates on L minus, when this Lz operates on L minus is equal to mh cross minus h cross psi m. Means when this Lz operates on lowering operator, then eigenvalue will decrease by the h cross. So this is a raising and lowering of angular momentum operator.